So we ran a summit, a HE Mathematics Curriculum Summit, in January. We invited the head of maths at all the maths departments in England and Wales. About half of them came or sent a representative. Okay, so there are about 54 in England and Wales. This is departments who are offering a G100 mathematics degree. And about half of them came along. And we also got education representatives from Institute of Maths and its Applications, the Royal Statistical Society, the OR Society. So those are sort of the professional bodies. And the Council for the Mathematical Sciences, which is an umbrella organisation representing those three with the LMS and the Edinburgh Mathematical Society. People from the HE STEM programme, Sigma, which is a math support network, and the MSOR network, which is my employer, and a few individuals. Anyway, for a good day of debate and discussion, and yeah, that's what I'm coming to now. This is sort of the structure of the day. We open with a debate. We believe memory, subject knowledge, and technical fluency remain vital for undergraduate mathematicians in the digital age. It's interestingly worded, and not many people are likely to vote against it, but it got people going. That was the idea of it. So on the one hand, we had somebody who's arguing that mathematicians do need to remember theorems and spit them out in exams and that sort of thing. And on the other hand, we had somebody who was arguing that really that bit of actually doing the mathematics, I mean, when you go into industry, you aren't given an hour and given no books and left to it, and if you haven't come up with a solution, then you can't build that bridge, you know. This isn't really how you work. And also, a lot of mathematics is this business of finding a real problem, turning it into a mathematical problem, solving it, and then turning it back into the real scenario and presenting it back to the person who's given it to you. And the solving it bit can sometimes, often be done with computers rather than with people. So that was sort of, anyway. Then we broke into 3 discussion groups. So the first one, we can't let them graduate unless. Okay, which is this question I asked you at the start about what's a graduate, what would you feel embarrassed if a mathematician you taught didn't know when they graduated, that sort of thing. So that came up with a list of sort of topics that we expect that a graduate should have some grasp of, I suppose. Number 2, if math students can't communicate in writing or speak in public, is that my problem? Okay, the group decided it was, and then wondered what they could do about it. Okay, but this is a problem if students can't put themselves across. I zipped in and out of these sessions. One interesting comment just as I came into that session. Somebody said, in industry, the people who can stand up and present the ideas to the managers are the people who are going to get promoted. And the people behind the scenes who are the mathematicians doing the work aren't going to get noticed if they can't stand up and fight their corner. That is interesting. And then the third one, if most maths graduates aren't confident in handling unfamiliar problems, should we care? Okay, so not accepting the data, but if it's true, should we care? And there was a lot of talk about how little, really, this business of taking a technique, you basically are taught a technique and then in the exam you see problems that are very much like the ones you've seen in problem classes and lectures and coursework and so forth. And how often are we assessing students on using that technique but in an unfamiliar area? Until possibly the dissertation and then certainly the PhD. Suddenly thrown in at the deep end, you know. So it's sort of, anyway. So those are the 3 discussion groups. Sure.
I just have to make a point about number 2. So some people are naturally very shy.
Yes.
And can't really speak in public.
Yes.
Nevertheless can do very good mathematics.
Yes. So some people are shy, can't speak in public, but can do good mathematics. Also, you've got to look at the types of people that you're attracting to your degree. Maybe people like that are more tending towards mathematics, and maybe that's not a problem. People do get by perfectly well. But usually, people end up if they go into a graduate training program or something like that, they have a bit of a baptism by fire to get them up to speed on this sort of thing, I think. Yes?
But at least they should be able to communicate in writing. Even if
yes.
they should be able to put together a good, well-worded report.
Yeah.
And if they do come speaking public, they should be able to use, at present, a slideshow.
Yes.
That sort of presentation.
So they should be able to
Help them a lot.
produce a good structured report and use something like these slides to try and help them through giving a presentation, even if they aren't brilliant at it, because a lot of it is practice, I think. But they should at least be on the way on that journey, I suppose. Writing reports is an interesting phrase as well, because again, we don't get students to do that very much, do we? The exam, the coursework, none of it's very discursive. Anyway. Where are we? In the afternoon, a chap called Jeremy Liversley from Leicester gave a talk about assessment that was quite interesting, and Neil Chalice gave a talk, what do students think about their degrees. Neil's one of the authors of the Black Book here, so he presented some of the findings from that book, interesting as they are. And then we got the 3 discussion groups back together to give some recommendations for targeting support for curriculum development, financial support, because my project has money to spend in this area. So I'll come to that in a second. We've made a findings report. The manuscript you can get online, and it says there it's currently being prepared for printing. What I mean by that is it went to the printers yesterday, I think, so it's quite possible that it is printed but not yet cut up and folded and stapled. But I'm hoping to have it next week. That's what it's going to look like. So this gives summaries of each of the sessions and summaries of the key findings. Now this just does a very useful thing for me because it helps me plan the next bit of my project. But I'm hoping also that having got together heads of mathematics, all their representatives from half of the universities in the country and asked them some serious questions about it, I'm hoping it'll be a good record of the current state of maths education. There's some really interesting stuff in there, particularly in the discussion sessions. So, it might be worth a read anyway. Is it going to go to the next one? Right, and then we have this funding call. This may or may not interest you because you may or may not be in a position to do anything about it. But my project's running until July 2012, so this funding is for the next academic year. Basically, the summit made this set of recommendations for prioritising this funding, and these have been taken forward in, it says 3rd call. We had 2 calls that were small scale, and this is the 3rd, the big push, to assign this money to things that are useful. So I spoke at the heads of departments of mathematical sciences have a conference every year, and I spoke at this last year, and I said, look, this is money that is available for you for things that you have told us that need doing. Please bid for it. So we'll see what happens. The call's open until the 13th of May. There are a series of work briefs based on summit outcomes. There's also open calls. So if you feel like you've got an idea that doesn't fit the ones in the brief, you can bid for any sort of project you like. I'm not saying you'll get it, but you can bid. These are the amounts. I think this is the slide I would have talked a lot about if you guys hadn't spoken much at the start. So, but I mentioned the graduate skills booklet projects being £1,000. Some of these are up to £50,000. So some of them are, there's a whole range of different things. If you're involved in that sort of area, I have just a few copies of the funding call documentation, and it's on the web. But if you come and see me afterwards, I can give you a copy of that. How to find out more, talk to me. Okay? Now, I'm running meetings. We've done the ones in Cardiff and Greenwich already. There are 4 more coming up, York, Birmingham, Manchester and Bath, where people can come along and talk to me about their ideas. I can talk to them about what the call is, what the projects are in a bit more detail, and they can ask questions about it and try and also you might, if you're a lecturer somewhere and you don't feel like you can quite take on one of these by yourself, you might meet someone at one of these meetings who will collaborate with you, etc., etc. And I'm here all 3 days. So if you want to talk to me, talk to me. Thank you very much. That's my name, my Twitter name, my email address, and the website where you can find out details of all these workshops and funding calls and all that stuff.